Alright, for our warm-up today, I want you to pause the video and look at these three sequences and see if you can come up with the next three terms for each. Alright, for number 1, we see 9, 12, 15, 18. So you might have noticed that each term is 3 more than the one before it. So 18 plus 3 would be 21, then 24, then 27. On number 2, you might have noticed that each one is going up by 5. So we'd have 12, 17, and then 22. The third one is a little bit trickier. It goes up by 1, then by 2, then by 3, then by 4. So our next one would be plus 5, which would be 24, then plus 6, which would be 30, and then plus 7, which would be 37. Really what this relates to is our understanding of what functions are. So today we're going to be learning how to represent functions with tables, graphs, or equations. A function is a rule that relates two quantities so that each input value corresponds to exactly one output value. And in that, there is what is called the domain and the range. The domain is the set of all possible input values, and the range is the set of all possible output values. Now we'll get to more of what that means, but another thing to keep in mind as we're looking through that is that functions can be represented in many ways, and those ways include tables, graphs, and equations. If the domain, which is the input of a function, has infinitely many values, it is impossible to represent all of them in a table, but we may use an equation to help show some of the values and to help in creating a graph. Now let's look at what we mean by all of this. So we're going to make a table and a graph of the equation y equals 3 minus x to the second power x squared. This is our equation. We're going to be able to use that equation to create a table of inputs and outputs and then use the table to make our graph. Now our input value is always our domain or our x value. Our output is what we get out of the function, which is our y. It's what it equals. So here we've just picked a 5 different input values. So this becomes 3 minus negative 2 to the second power. But negative 2 to the second power is really 4. 3 minus 4 is negative 1. Then this becomes 3 minus negative 1 to the second power. Well, negative 1 to the second power is 1. 3 minus 1 is 2. Then here we have 3 minus 0 to the second power, which is still just 0. Then we have 3 minus 1 to the second power, which is still just 1 again. And then 3 minus 2 to the second power, which would be 3 minus 4, which gives us negative 1. And now we can graph these values. So remember, x is always first, so we have negative 2, negative 1, and then we have negative 1, 2, and then we have 0, 3, 1, 2, and 2, negative 1. So if you notice, when we graph this, it makes a U or a bowl-shaped function. So now it's your turn. I want you to go ahead and make a table and graph for the function y equals x plus 1. Alright, so here we're going to put in our values. So we have -1 plus 1, which would be 0. 0 plus 1, which is 1. 1 plus 1, which is 2. And 2 plus 1, which is 3. Now we're going to graph those points. So we have -1, 0. 0, 1. 1, 2, and 2, 3. Now on this one, you may have noticed we didn't get a bowl shape. We actually have a line. So we can go ahead and draw our line on our graph to represent our function. So let's go ahead and talk a little bit about what it means to actually be a function. So remember, a relationship is just kind of talking about sets of ordered pairs. And if a relationship is in fact a function, that means that each input has exactly one output value. So that when the relationship is graphed, we can use what's called the vertical line test. So remember, vertical, like in basketball, is up and down. Okay, so if we place a vertical line on the graph, and if the line intersects the graph at only one point, then the relationship is a function. If the line intersects the graph at more than one point, then the relationship is not a function. Basically what this is saying is that if I was to take a value and substitute it into an equation, as long as I only get one answer, it's a function. If I get a value that's giving me more than one answer, then it is no longer a function because there's multiple outputs for one input. So let's look at what this means. So we're going to use a table, and then we're also going to look at a graph to determine whether the relationship represents a function. So with our table, what we're going to do is we're first going to look at just our x values. Okay, so here we notice that I have two x values that are the same, and then two y values are the same. Now with our two x values, we have to check, those are our inputs, to see if the outputs are different. So here we have an output of 3, here we have an output of 6. Since these two are different, this is not a function because 2, which is our input, has two different output values, one of 3 and one of 6. Even the same thing if we look at the 3, we see that one output value is 4 and one is 5. Now for this next one, I'm going to show you what we were talking about with the vertical line test. So what I'm going to do is I'm going to go ahead and take and draw a vertical line. And I'm just going to drag it through my graph. So what happens is if I start at the left and drag it through the graph, as I go, I just want to check to see if my vertical line is touching what I've graphed in more than one spot. So for example, if I was to stop right here, you notice that I'm crossing the graph at this point and at this point. So that means for our input value of -1, there's actually two output values. There's one at 2 and there's one at a little bit less than -2. Since that happens, this is also not a function. And I can just keep moving that graph and it's that same idea. So there's multiple spots where our graph would cross our vertical line more than once. So now we're going to go ahead and graph using an equation, make a table, and then graph to determine if it represents a function. So here we have y equals x to the third. So my y value here is -2 to the third, which would be -2 times -2 times -2, which is really 2 times 2 times 2, which is 8. We have an odd number of negatives, so it becomes -8. Here we have -1 times -1 times -1, which is just -1. 0 times 0 times 0 is just going to be 0. 1 times 1 times 1 is just going to be 1. 2 times 2 times 2 is going to be 8. So now I'm going to go ahead and graph. I have -2, -8, which is actually off of our graph. And then we have -1, -1, 0, 0, 1, 1, and then 2, 8. Right here, -2, 8, right here. So if you notice on this one, our graph kind of looks like that. Not quite linear, it kind of makes an S shape. If I were to draw a vertical line here, okay, and then move it across. Now it does look like it touches in more than one spot as I go, but the other way we can look at it is if we look at all of our input values, notice none of our input values repeat, and then so then none of them have a output value that we have to worry about. So even though this one doesn't really look like it because of these steep curves, my graph isn't the greatest either. This is actually a function. So now it's your turn. I want you to go ahead and pause the video and look at our two relations and then determine whether or not they pass either the vertical line test or the definition of what it is to be a function. So in our first one, since none of my x values input, or my input values repeat, we don't even have to worry about looking at our output. So this would be yes, it is a function. On my second one, I'm going to go ahead and draw that vertical line, drag it across. If you notice this time, each time when I go across, I'm only touching that red line in one spot. So this is also a function. You probably have quite a few questions, and that's okay. Just make sure you write those down and let me know, and then you can go ahead and get started on your work.